So let's look at the final type of interaction effect. This is where we have to multiply a continuous variable with another continuous variable. So let's just suppose that we have this simple equation where we have a dependent variable, which of course is continuous. We have two independent variables, x2 and x3. And because I want to test the interaction of x2 and x3, I need to create a multiplicative term for x2 times x3. But x2 is a continuous variable and x3 is a continuous variable. And let's just, for example, they may both range from 1 to 10. So x2 ranges from 1 to 10, x3 ranges from 1 to 10, and y is a continuous variable. And I assume that there's an interaction effect between x2 and x3. Generally, we can say, in this particular case, that if beta 4, the interaction term coefficient, if beta 4 is significant, then there is a significant interaction between x2 and x3, which means that the effect of x2 on y is contingent on the values of x3, and it also means that the effect of x3 on y is contingent or moderated by the values of x2. Right. Now, second, we can note that if beta 3 is a positive number, then the effect of x2 on y becomes this guy here. This effect becomes more positive as the values of x3 are higher. Likewise, a positive beta 4 would mean that the effect of x3 on y becomes more positive as the value of x2 are higher. Third, just change this to third. Third, if the interaction coefficient is negative, then that means that the effect of x2 on y becomes more negative as x3 is higher. Likewise, it would mean, that is, if beta 4 is a negative number, that would also mean that the effect of x3 on y becomes more negative as the values of x2 are higher. This is just sort of a general guidelines for how to interpret the coefficient for interaction effects when both the variables that constitute the interaction effects are continuous. So let's use this example. I'm going to use Icelandic data from 2020, and I want to examine effects on xenophobia, or fear or hatred of foreigners. And I've created a scale. This is the same scale. Yeah, I've created a scale. It's actually an index. It's created by finding the mean response on two scales. But the values on the xenophobia index range from 1 to 5. I'm going to assume that age influences xenophobia, so older individuals are more likely to be xenophobic. It's what research shows. Younger people are more tolerant of immigrants. There may be an effect of gender. Education may have an effect. So, those with less education are more likely to experience or to sense or to think that there is competition from immigrants about their jobs, and also, immigrants may be more satisfied with less pay, if they're in uneducated jobs, and this may trouble individuals that do not have education. So degree might influence xenophobia, and I'm going to use bachelor degrees and graduate degrees to represent degree. Household size, it's necessary to control for household size because bigger households will need higher incomes to be financially well off. Household income may impact xenophobia. So those who have low incomes may experience maybe more likely to experience threat from immigrants who are often also low income and competing for the same jobs. And also, finally, experiencing difficulties, financial difficulties at home may create frustrations that people may use immigrants as scapegoats for their troubles. So that might influence xenophobia. Interestingly, we may expect an interaction effect such that having a low household income may be more likely to produce feelings of xenophobia if there's economic trouble. So, income is such a, people with the same, two households with the same income may be very differently financially situated because, some households are in debt, have their own apartments or have to rent, may have, there may all sorts of reasons to expect that the same income level does not necessarily imply the same economic trouble. So we might expect that when economic trouble and low household income come together in the same household, then there would be a good deal of xenophobia. Anyway, it's just something to test here. So I expect an interaction effect between household income and economic trouble. One more. So I'm going to expect that the effect of low income on xenophobia will be heightened or bolstered by economic trouble. So more economic trouble, the higher, the stronger the negative effect of income on xenophobia should be. Anyway, so first the additive model. This would be our additive model. So like without the interaction effect, xenophobia is the function of age, female, college basic and college graduate, household size, work status, whether you're student, disabled, retired, or other. Okay, so that's going to be the additive model. So let's just first look at the findings for the additive model. And I'm going to run this variable descriptors at the same time. And this will become important. So I just have this data here. And I'm just going to show you the variables first. So here is xenophobia. Ranges from 1 to 5. Age, 18 to 98. We have female, a dummy variable, 0, 1. We have college basic, so bachelor degrees versus other, and college graduates, graduate degrees versus other. We have students, we have disabled, retired, and other. And the reference category for these 4 dummy variables is working. We have how many people live in the household, with a maximum of 9 here in this data. We have household income groups. So income is divided into 5 groups, with 1 being the lowest income per group and 5 being the highest income group. And then money trouble is a subjective question about whether people find it difficult to make ends meet. Well, the household has difficulty making ends meet, where 1 equals no problem and 5 equals maximum problem. Okay? And we are going to run the regression now. And I've already set up, so xenophobia is the dependent. We have age, female, college basic and graduate. Size of household, student, disabled, retired, other. And Okay, so if I'm just gonna show you again the additive model. So I forgot to add household income and money trouble to the equation. So I actually have, age, female, education, size of household. We have working status with the 4 dummies, and then we have household income, which ranges from 1 to 5, and money trouble, which ranges from 1 to 5. So I'm going to add them to the regression also. Where's my regression here? Right, so we have household income, we have money trouble, and I'm going to do paste. And I'm going to run the command here, like that. Now, I'm going to note here that, and we're going to use this information later. So here's the descriptive statistics from the analysis, just the means and the standard deviations of all the variables. And we can see that the mean household income in the data is 3.0583 on the 1 to 5 scale. And money trouble, the mean is 2.2411 on the 1 to 5 scale. We're going to use these numbers later, the means of these variables. So we go down, and we have the output for the additive model. And this is the additive model. So we get an R-square of 0.18. So we're explaining about 18% of the variation in xenophobia. And I have the findings here on the PowerPoint that I just showed you in the SPSS. So just real quickly for practice, we can see that age is positively significantly associated with xenophobia. We can see that graduates and bachelors have significantly less xenophobia than individuals who have less than college degrees. Right? So education reduces xenophobia. There's no significant difference between males and females in terms of xenophobia. No significant difference. We can see that if we look at work status, these 4 variables, student have less xenophobia than working people, significantly. The permanently disabled have more xenophobia, significantly, than working people. And the retired, interestingly, have less xenophobia, significantly, than working people. And here we are controlling for age, for the positive effect of age. So net of the positive effect of age on xenophobia, retired people actually have less xenophobia. And then we also see that others are not significantly different from working people. And interestingly here also, income and money trouble, these 2 variables, neither of them has a significant effect on xenophobia. So it seems that economic status actually has no effect on xenophobia once we have education in there. So it's all about education and age and work status, and it's not about economic status per se. However, we might be hiding the effect of economic status if there is an interaction effect between household income and money trouble. So maybe income has an effect on xenophobia if money trouble is large in some households. We cannot see that in this equation because it's an additive model. So now we're going to examine the interaction between income and money trouble. And here what we need to do is that we cannot use the variables as they are, that is income and money trouble. We need to center them first to be able to multiply them together. We can actually multiply them together without centering them, but it's going to produce a scrambled set of results. So we really need to center them first. So before multiplying income and money trouble together, we need to center these variables. And how do we center a variable? Well, we subtract the value on the variable. We do the variable minus the mean value on the variable. So for each individual, we take each individual score on household income, and we minus the mean value on household income. So centered household income is a variable that is really indicating deviations from the mean. So the new variable will get mean of 0, but it will have the same distribution. I'll be moving the mean on the variable to 0. And I do the same for money trouble. I do money trouble minus the mean value on money trouble. This creates a new variable that has a mean of 0, and in other respects the variable is the same. So let me show you this in SPSS. So I'll just show you I've already done this here. So if you look here, first I create a variable for household income that is centered. I call this variable C house income, and the variable is household income minus the mean on income. And I already we found the mean on income in the output just a few minutes ago. The mean income is 3.0583 on the 5 category variable. So centered household income will be household income minus 3.0583. And I can run this out. Then I'm going to center money trouble, and that's going to be money trouble minus the mean on money trouble, which is 2.2411. And just to reiterate, we found this in the output. Here I asked SPSS to produce descriptive statistics when I ran the regression, and here's the mean on household income, 3.0583. Here's the mean on money trouble, 2.2411. Okay, and I can run these variables, right? And now I just created, I'll show you in the window here. Now I just created, let me throw this out here. Now I just created these two variables, C house income and C money trouble. I'm just going to show you what they look like. So centered household income has negative values and positive values. It only has 5 values, and the mean value will be 0. Okay? I just moved the variable, I just centered the variable. It has the mean value of 0 now. And I did the same for money trouble, which now will have negative values and positive values. So individuals that now have minus 1.24, they formerly had the value 1 on this variable, etc. And now I can multiply these two variables together like that. So what I did here is that I just did compute, and then I wrote down the names. I wrote down the name that I want the variable to be named. So C home income times C money trouble. This is the name that I want to give the multiplicative variable. And then I need to multiply the variables together. So I'm going to multiply C house income times C money trouble. Okay. And this is and now I can run this variable here. And now if you look in the data window, you can see that this variable has been created. Okay, so centered household income times centered money trouble. And now I'm ready to add to the regression. And look now. So we need to go to the regression window, and we need to throw out the uncentered variables for house income and money trouble. And instead, we need to put the centered variables for house income and money trouble. These are the centered variable, and then the interaction term where I multiplied the centered variables together, And that's how I get this final output with age, female, 2 dummies for college, household size, 4 dummies for work status, centered household income, centered money trouble, and the interaction between the 2 centered variables. And I'm going to go to the PowerPoint to show you the results. Okay. And now we should interpret. Okay, so let's interpret. Let's interpret this large model. So the dependent variable is xenophobia. Okay, so this model is a combination of additive and non-additive effects. So if you look at the screen here, this part of the model, these are all additive effects. They're non-conditional effects. This part of the model, the one containing centered household income, centered money trouble, and the interaction term, this is a non-additive. This is the non-additive part of the model. Okay? Starting with the additive part, we can still see that age is positively significantly related to xenophobia. Having college degrees is negatively associated with xenophobia. So those with bachelor's and graduate degrees have less xenophobia than those who are less than college degrees. There's no significant difference between males and females, and there is, in fact, no observed difference either. Household size has no effect on xenophobia, no significant effect. Students have less xenophobia than working people, significantly. The disabled have more xenophobia than working people, significantly. And of course, this is controlling for all other effects in the model. The individuals who are retired have less xenophobia, significantly, than working people, controlling for all other effects in the model, including age and education. There's no difference between other and working. Okay, and now we come to the non-additive model. The first thing we do is to look at the interaction effect. And somewhat disappointingly, it would have been nice to get a significant effect since we are learning this. But there is no significant effect between income and money trouble. So the data does not support the notion that the effect of income on xenophobia is contingent or moderated by money trouble. Right? So there's no significant interaction effect. So now we would have to conclude that actually economic status has no significant effect on xenophobia when controlling for work status, education, and age, right? And we've even tried the interaction between the two, and it didn't produce any significant effect. Now, just for understanding, we should, I'm just going to focus on the, I'm just going to focus on the non-additive part of the model now, and just explain, why did we have to center the variables before creating them, or creating an interaction term. So here I've just produced the non-additive part of the model. So I'm skipping all the other variables. So we have centered income, centered money trouble, and the interaction term. Okay. So let's focus on the effect of income in this model, and let's just ignore the fact that the interaction was not significant. So this coefficient here, this is the effect of income on xenophobia only when money trouble is at its mean. And I'll show you how. Because if money trouble is at its mean value, that is 0, then we would plug in 0 here for money trouble, and we would plug in 0 here for the interaction term, and we will end up with minus 0.5 household income. Right? So this is the effect of household income on xenophobia when money trouble is 0. Or, in other words, when money trouble is at its mean. So this is the main effect of household income. Okay. In short, the interaction term was not significant. If it would have been significant, it was a positive coefficient here. So if the interaction effect would have been significant, we would have concluded that the effect of household income on xenophobia would be ever more positive as money trouble was higher. But that did not turn out to be the case because it was not significant, the interaction effect. So that concludes this recording of interaction effects.